data integration with Airbyte and Delta Lake. I am honored to have Simon on board. Now, we're going to wait a couple of minutes before we actually start the show in reality, because we're currently restreaming live to both the LinkedIn and YouTube platforms. So meanwhile, as we're waiting for folks to jump on in and discuss with us, love to go ahead and actually start with the fun stuff, which is where are you based out of? Oh,
I'm based in Switzerland. So yeah, waiting for the snow right now so I can go snowboarding and cross-country skiing. Yeah.
Oh, okay. So whereabouts in Switzerland are you based out of? I'm curious.
Based.
Oh, like, so which city in Switzerland? Sorry.
It's Bern. It's like the capital.
Oh, Bern. Okay.
Yeah.
Okay. Oh, excellent. Okay. Yeah. No. So, okay. Are you okay? Now, here's the real debates, because even though I know this is supposed to be about Airbyte and Delta Lake, which one do you prefer, snowboarding or skiing? Because I know that itself becomes a bit of a discussion, to put it lightly.
I'm a long time snowboarder, but as I'm getting older, I switched more to cross country. So I'm now.
Wait, Simon,
doing the old stuff.
Simon, you're telling me you're older. How old are you? I'm just curious. How old are you?
36.
Okay, so be quiet when you say stuff like that. I'm almost 50. What are you talking about? You're older. Oh my goodness.
I'm getting older, yeah. So I don't like to go up anymore in the mountain and stand in line. And so in the cross country, you're always like in the valley, and it's much more relaxed in the nature. But yeah, that's a sign that I'm getting older. But still, I like snowboarding a lot.
Okay, so yeah, this might turn into a snowboarder versus skiing debate here. No, I'm actually all for cross-country skiing, and because I love doing that, and I actually do a lot of snowshoeing as well. Sorry, I should rephrase it. I used to do a lot of snowshoeing as well.
All right,
but I actually started off as a skier, and then especially in East Coast Canada, and then now I live in Seattle. So now West Coast, so that has plenty of powder. So because there's plenty of powder,
oh nice.
I started switching over to boarding just to give it a try, and basically, you know how like people make fun of snowboarders because basically it's okay to fall because it's part of
the fun
boarding. Right? Yeah, it's part of the fun of boarding. Yeah, so when you have lots of thick powder, basically it's like you're sort of hosed either way, because whether you're doing, unless you continue with a specific speed, you're sinking either way, basically. So it doesn't really matter.
Yeah, if you sink too deep, then it's very hard to get out. So that's the dangerous part of it. But otherwise, it's so nice to slide.
Absolutely. Yeah, absolutely. All right. So I think we are live on both YouTube and on LinkedIn. So I think that, and we've been live on Zoom this entire time. So this is perfect. Really happy to have all three platforms working. So perfect. Well, okay. So now that everybody's live, let's go ahead and reintroduce yourselves to explain what session this is. Again, this is a D3L2 session discussing data integration with Airbyte and Delta Lake. So for starters, Simon, why don't you introduce yourself? And so that way people know who you are, and then we can dive right into it.
Okay, yeah. Hi, everyone. My name is Simon Späti. I'm based in Switzerland. And I like to call myself like a data engineer and technical author with like 15 years of experience. I started with the classical BI way. So I started building data warehouse with Oracle and Microsoft. Then I had a stage in Denmark, like 2-3 years, where I got into so-called big data. And I learned more. Before it was all like PLSQL, TSQL, and there I learned more like Python and coding. And when I switched back to Switzerland, I also got more into the real data engineering with also setting up with Kubernetes and like open source stack and stuff like this. And as a side hustle, I also started to blog. So that's where I also got a little bit more into all the open source stuff. So I like to spread the word for open source, and also kind of interested in any kind of new stuff just to get my hands on and try it out. So now cool. Mainly at Airbyte, and doing data engineering and technical writing. Yeah, that's my current job.
Perfect. Actually, I'm going to have a couple questions just because when were you doing SQL Server data warehousing? I'm curious. Was it like back in SQL Server 2008, 2012, like
2008 to 16, most of the time.
Got it. Okay. Yeah. So did you ever play with analysis services, or were you primarily playing with SQL Server itself? I'm just curious.
No, analysis service was the main thing. So I basically always built something with SSIS, and then I built cubes, and then I had to explain trying to build dashboards on top of it. And SSIS is actually a cool tool because it's still running hot at some companies. So
I know, isn't it scary? So Simon, you and I, you can tell that Simon and I did not bother prepping each other for stuff. I don't know if you knew this. I actually was on the SSAS team back then during the time you were.
Oh, really?
Those years,
That.
Yeah. So back in 2000. I want to say 2011. That was when Dave Mariani from Yahoo, he was at Yahoo at the time. He's right now the co-founder and CPO of At Scale. But at the time, back in 2011, he and I had went to Hadoop World. That tells you how old we are when we're referring to Hadoop World, okay? To talk about the largest analysis services cube on the planet. At that time, the cube was 24 terabytes on top of a 5 petabyte, 2 petabyte. I'm sorry, 5,000 node, 2 petabyte Hadoop cluster. So back in so it was using the largest, most expensive staging server on the planet because it was an Oracle rack server. That actually,
But could you load it during the night, because that was always.
No. This wasn't a nighttime load. It took us 3 days to load. Okay. 3 days to load a quarter's worth of data.
Oh, nice. Until you found out that you had an error, and then you had to do it all over.
Yeah, exactly. So often Dave and I would talk about how we would replicate the data, and we would go ahead and actually have multiple cubes up and running. We had to understand the infrastructure super well, so that way we could clone physical clones of the data, actually at the hardware level, physically clone the data in order to be able to go ahead and keep it up and running, and knowing full well that this thing could crash at any moment, and then we have to have physical clones. And so we have both the physical clones from the Clarion machines, EMC Clarions, and also the logical clones. So we were messing around with all of these things. This is
it's a big part of my career, that I used SSAS.
Okay, so I either you're welcome or I'm sorry. I'm not sure which one it is.
No, I think it serves me well, and also now I'm basically trying to recopy the same thing with larger amounts of data, because now it doesn't scale, right? That it is very good for smaller amounts of data, but now for big data, I would like to have the same experience that I have, sub-seconds or seconds response time. And that's basically when you're facing a BI dashboard or a customer-facing dashboard, you cannot wait 3 seconds when you click on a dashboard. So I'm basically trying to recreate the experience I had back then, but with bigger data and newer tools.
Gotcha. Oh, but by the way, I just forgot to do some important logistics, but then we'll switch back to that which is if you have questions, go ahead and chime us in on the LinkedIn. If we're not actually right now, I haven't seen any questions on LinkedIn, but we've been noticing some issues with LinkedIn comments. If you are running into issues, go to delta.io/events, and then just click on the event and join us on the Zoom, where you can just ask us questions directly there. Okay, so just as an FYI, or you can go ahead and just join us at YouTube. You can also ask questions there if you want to do YouTube instead of LinkedIn, and that's go.delta.io/YouTube. It's the streaming event. So so hopefully if you're not, if we don't see right now, again, I'm not seeing any questions through LinkedIn. That's one of the more popular platforms for us. So if I'm not, but you do want to ask questions, please go to either the Zoom, which is, like I said, go.delta.io/events, or the YouTube, go.delta.io/YouTube, and you can just join us there and then ask your questions away. Okay. And so, for example, Medio just chimed in, SSAS will stay in companies until the people that deployed it retired. And yeah, I actually absolutely agree with that statement. So to give you some context on, and Simon, I'm pretty sure you suffer from the same thing here, right? I'm sure you have your own story of this one, where what happened is that because I was working with Yahoo on that uber large cube, right? What ended up happening is afterwards is that we would continue having these discussions. And then I realized about 6 months later that we were having these weekly discussions. We didn't talk about a single Microsoft technology. we were talking about Hadoop, and we were talking about Spark. So this is during the transition where the Yahoo team actually was starting to switch over to Spark themselves. So literally I was going like, wait, I've been talking to Yahoo for 6 months as an employee of Microsoft, and I haven't talked about a single Microsoft technology for 6 months. Maybe I should change gears.
That's maybe also why it didn't change that much, because that was one thing. It already had a lot of capabilities. It built in very early on. Even machine learning was there from the 2008 or 12.
2000. Actually, technically, even before that, technically there was the data mining add-in back in 2005.
Yeah, exactly. Okay, wow.
Yeah.
But it didn't got updated that much.
Oh, right? No. It didn't get updated. Yeah. There are stories I can get into that, but unfortunately, I'm pretty sure I'm still under NDA for that, so I'm not going to say anything.
That's awesome.
Cool. All right. So now you this is sort of cool that both Simon and I can talk about our analysis services or BI past. So just like you were noting, like as you transitioned over to joining, like when you moved between Denmark back to Switzerland, okay, that you were saying that you had like basically started working on big data, and then we'll talk about the BI stuff and all back into big data space. But I'm just curious, so when you switched over to big data, was it Hadoop first as well, or was it more Spark? I'm just curious, or something else altogether. Sorry.
First, it was only like Python, and I worked at like a subsidiary of Airbyte, and there we used like Palantir. So that was like all built-in tool. So basically, you could just use SQL or Python already back then and build your pipelines and stuff. So that was quite cool. But fortunately, I didn't have to work with Hadoop. So when I transitioned, the first thing was Spark that I used for like massive amounts of data.
Perfect. Sorry, actually, we got a question about the analysis service that just popped up on LinkedIn, but let's continue this conversation. We'll bring it back to AS afterwards. So yes, Saurabh and anybody else on LinkedIn, if you guys want to continue asking questions on analysis services, as you can tell, it's close to both of our hearts. So yes, we'll go back to it. But we've already transitioned to Spark, but we'll make sure to leave time to go back and talk about analysis services. So don't worry, okay? All right, so you got to Spark. Which version of Spark were you working at the time? Like, were you working Spark 1.3, Spark 2.0? I'm just curious.
Oh, I'm not sure. I think, when was that? 2000. I was quite late to the game. So that was, I just used like a Databricks cluster and used whatever was there. I think it was before 3.0. So it was
gotcha. So probably 2 dot something. Got it. Okay. Yeah. Oh no! I was just, the only reason I'm asking is because I just want to remind myself to see how much pain you were going through. But it looks like you did at least didn't suffer from some of the earlier pains that we had. So
I suffered from the long error messages in Python and where you could still do stuff in Scala but not in Python. But afterwards it got all transferred to Python as well, right? But when I started, Python was not yet, like I would say, I think most people use Python, but it was not like the main API from Databricks perspective.
No. You're absolutely right. I mean, the Python API, like basically, is like I still remember Randall talking about like when we originally built the Python API was originally built was like 2,000 lines of code, which was just an abstraction layer. And because we always love the fact that Python on top of, which is built on top of C, basically, is doing an abstraction layer over the JVM, because that makes a ton of sense. I'm, by the way, for anybody who's Pythonic and not knowing who I am, I am being very sarcastic when I say this, so don't worry. Okay, so in fact, we will eventually talk about Rust, so don't worry. This will all start making sense. Yeah, don't worry. We're this is sarcasm here. Okay, so, but you're absolutely right. Like basically, the error messages, we would just literally spit out the Scala-based error messages which themselves were already confusing enough as it was. And then to anybody who was an expert in Python or just used to using Python, like you're looking at these Scala messages, you're going like, okay, wait, what is this?
I feel like I still feel the overwhelmed when I think about it. So that was quite, and then you Google it, and most of the time it was something completely different than to the error message that, or at least to the stack you were following. You had to take like a follow one track. But
Well, especially because during those early years, we often were talking about like PyFunk, right? So basically, it was like the idea that each of the workers actually had to go ahead and spin off of their own like Python process within the worker itself, and then you had to go Py4j. So it literally was like the JVM back to Python. So Python to JVM, JVM back to Python. And then later on, we started going ahead and saying, okay, no, we'll put more of the stuff in the driver, which of course all we did was overload the driver. I'm like, oh, that's great. So yeah, like as you can probably tell, we can go on for hours, so we'll probably switch gears out of this because I can rat hold on this one particular topic. As you can tell, there's a little bit of trauma for me. In terms of basically like when we started doing vectorized UDFs, so that way it can make our lives a little bit easier. But saying that, let's talk a little bit about your story into Airbyte. Like, so how did you get involved with Airbyte? Was it because, like, you know, invariably like the ELT versus ETL side of the house, or just interesting? Like you mentioned you were Airbus before with Python. Yeah, how did that transition over to Airbyte? I'm curious.
Yeah, this is mainly because of open source, and because I'm a big believer in the product of Airbyte itself. I built like ETL or ELT pipelines at every company that I have been with. So basically you start work, and then either there is already something like a template, mostly custom built. And I just found the idea that you can reuse and build it in the open so appealing. And it was also soft reason that I wanted to work remote. Airbyte had these opportunities that you can work remote, and also I really like coding, but I also like writing, and this was actually the only job I found like where I can work as a coder or data engineer and writing. So that's how I got started. But it's also because I write about the open source data stack tools, and Airbyte was one of them that I really like, and so that's how I found the job essentially at the end. Yeah.
Oh no, that's great, and it actually makes a lot of sense. I mean, just to give some context for folks, like, you know, developer relations itself. Now, mind you, of course, we're doing shameless. I'm doing a shameless plug on both of our behalves of our actual roles, but in a lot of companies, this is starting to pick up the need for exactly what Simon just described, which is this idea that you can still code, but also be able to, you know, speak or to be able to write, to be able to communicate that effectively. And there's that interesting balance, and dev relations actually allows us to do that. Now, let's focus a little bit specifically on Airbyte, though. Okay, so you talked about, okay, you started using yourself, you started using for coding purposes, a suite that makes a lot. Open source, again, makes a ton of sense. Why don't we go backwards a little bit, though, right? Why Airbyte? What is it about Airbyte? Okay, so for this audience here, since this is the Delta Lake audience, they may or may not be familiar with it. So why don't we start just even with that? I mean, you know, like why do we care? Why is Airbyte such a cool thing in the first place? And yes, it is cool. So don't get me wrong. If you want to just use Airbyte just for that reason, that's a valid reason, honestly. But no, I'm sure there's actually like valid technical reasons. So why don't we talk about that? Like, what's the valid technical reason for Airbyte?
I think for Delta users, it's especially cool because before you use Delta, you need to have some data, right, that you need to load. So basically, you create your Delta or data lake, and the first challenge will be, okay, how do I get in this data? So is it an API? Is it a database? Is it like a Excel sheet? Is it like SSAS cube? So whatever it is, you need to have to integrate that, and that's basically what Airbyte does. So we have like 330 connectors, source and destination. So like the destination will be the Delta Lake, so that you can basically, you might have some Google Analytics data, you might have some Facebook ads, you might have some Oracle databases, you might have some Microsoft, whatever you have, you need to integrate that into your Delta Lake or your data lake to make sense out of it. And that's essentially what Airbyte does. And the best thing is it's open source, right? So it's you basically, you don't lock yourself in. So whenever you have a problem, you can just look at the code or the connector and actually fix it. Or if you're lucky, if it's a well-established connector, maybe someone else already fixed it. So it's because the hard part of the connector is not like building it. The hard part is maintaining it, because these APIs, they change all the time. So it's really hard to maintain it. And in my opinion, I'm a big believer in open source. The best thing is with open source, right? Because then you can work together on that. And there's more reasons. We have like a CDK, so like a connected developer kit that you basically don't start from scratch. You can just yes, start up with existing code, we scaffold some stuff, so you're very fast. Just a couple of weeks back, we introduced a low code connector. So that means you can just, some love it, some hate it. So with YAML, you can just like declaratively like design your connector, which is not good for everything. But when you have an API, you don't need more, right? You just have an endpoint. You have like maybe the pagination, how many data you want to do in one go. Maybe you have different tables and the APIs. There's only a couple of things that you do with an API. And that is what we wanted to tackle with that low-code connector, that basically everyone can build a connector within a couple of minutes, hours. So it's really fast, and it's also easy to maintain because it's just a YAML file instead of, if it's code, it's always harder because it's obviously bigger and you need to do more. And but we support different languages. We have Python, Java, C#, JavaScript, and so on. But because we run in Docker, you can essentially build any kind of connectors. So that's also a nice thing that I think we have, is that we are language agnostic, and you build the connector in the language you feel either most comfortable with, or even better, that is most performance, right? So that it's
No, that makes a ton of sense. So where I'm coming from then is you sort of implied the answer here, but let's dive into this a little bit. With Airbyte, basically you're able to connect to all of these different sources, and so it takes care of the key point of the ingestion point, which is basically how do I connect to a source and how do I get to a target. Because you're following open source, the idea is that you've simplified the processes massively. And so from your perspective, especially what are the primary complexities that like you say, the Airbyte customer base is typically going to? Is it just that connection point? Is it just the low code? I'm just curious, because ultimately it's about getting to that point of data integration, right? So that's ultimately what you're trying to get into. So I'm just curious, is that, from your perspective, from Airbyte's perspective, is that like the number one reason why people are having a hard time building their lakes in the first place, or ultimately their lake houses?
Maintaining a lake house, I think you have other challenges, but when you don't have any data, I think it doesn't make sense to build one. So I think you wouldn't need Airbyte if you have like one huge source that you have everything from. But as soon as you already have like Salesforce and maybe some SAP or just like 2-3 others, I would definitely go for Airbyte already. You can also use Airbyte for whatever connector is there and still build your own. Right. It's even easier with Airbyte because you have the customer developer kit that supports you along the side. But I think, I would. That is probably the most. And then the challenges that's what I said before, right? That they just changing all the time, and there is like new SaaS products every day. So that's another challenge. That
right.
Almost every product that gets built these days, they're creating data as well, right? So it's essentially a new source, and you cannot really tackle that problem with a closed source approach, in my opinion, because you will just be too slow, and the people they want also to like fix their stuff fast, right? If they have a highly demanding connector, they cannot wait for someone else to fix it. So not everyone has the skills or the engineers to fix it themselves, but at least you have the code and you can really fix it. And then the next step is obviously like integration. So you would then integrate with like Orchestrator or with Delta Lake, or that's then the next thing. But I think it mostly data-driven or data architectures start with integration, then transitions to like of course you need a store. So where do you store it? And then you have like you have like, I always like to call it 3 levels, right? You have like the object store, which is basically a dump store where you just dump some files. And then you have like the file format, which can be like Apache Parquet or all the others, which basically
or JSON, whatever else. Yeah.
Exactly. So best thing is when it's like optimized for like storage. So it's like compromised and maybe even a columnar format that you can like do analytics queries. And then the next level is like the table format, right? Which Delta Lake is obviously very good, where you get like I always like to call it like a database for distributed files, because you, essentially you get all the features that the database has, right? So you have like asset, transaction, you have time, you even get more. But it's like a table, but under this table is like huge, it can be massive files, right? So it's, for me, that was quite a big eye opener when you can do like database stuff based on files with, and yeah, that's also where I used Delta Lake in my previous work also heavily because of that fact, because it's just so, it's open source and it's also so nice to use and have all the features that you basically know from databases. Yeah.
Oh, no. Trust me. It's funny that because like I said, when you and I started chatting, we actually didn't chat about our past. So we're coming from a very database centric world. And that's actually the whole reason why we're commonly talking about Delta Lake as a lakehouse format in the first place, because exactly to your point, the advantages of the best of both worlds between data lakes and data warehouses, right? The asset transactions, time travel, schema evolution, enforcement, things that you would normally associate with a database or a data warehouse, but you also have the flexibility and scalability that's normally associated with a data lake, right? So you put those two, because I mean, like I want to avoid the past of schema on read. I'm definitely guilty of the like, oh yeah, we'll just put everything on Dupe and we'll just do schema on read and everything will solve itself. And then like that, I think that lasted for me all of 3 months, and I'm realizing this was a really bad idea. I never should have said this in the first place. Right? That type of thing. So
yeah, it's a good thing and a bad thing, right? Because you can store things without thinking, and it's fast. But yeah, you're just causing like mostly data silos, and after a while you need a data catalog just to know what data you have.
Exactly.
Which, so you start to adding on top of it, although, you should probably know your data and think about, it's always, I had both worlds. So with a data warehouse, I was also frustrated because you're so slow, right? Whenever someone said, oh, can you get me this new table? Oh, okay, that takes 3 months. Okay.
Right.
So it's like, because you need to deal much more, right? You need to think about how you want it, what granularity do you want, like every event, or can you like aggregate it? And so there's much more thought. So it's also nice to just store it. But obviously they both has their pros and cons.
Oh, absolutely. So this actually is a nice segue to the other topic I want to discuss a little bit, which is like ETL versus ELT, right? And so the idea, and so for those who are listening right now, they're thinking, hey, what the heck are you guys talking about? We're talking about extract, transform, then load, which is prototypical of something system where you are outside of the database, where you're doing the transformation there per se, or outside the storage, I should probably put, versus ELT, which is extract, load, then transform. In other words, which is prototypical of a lot of databases and data warehouses, which is saying, no, extract the data from multiple sources, load it into this one thing, and then transform it in that one thing. So I'm just curious from your perspective, like, pros and cons. Does Airbyte allow for both? Like, is there a preference? I'm just curious from, your perspective, whether it's yourself personally and or from an Airbyte perspective. I'm just curious.
Yeah, this is actually also a feature that not many people know about Airbyte. We sometimes call it like small t LT. So there's a T inside the ETL and load, because under the hood we also use dbt for transformation. So you can actually, within Airbyte, you can do transformations, which obviously should be like small things, because otherwise you break stuff. But we actually have the ability to do transformation in front of the loading it, right? So you have the transformation twice. So this is very nice actually for like GDPR stuff or like security stuff, because you can actually take away PII data that is sensitive before you load it to a data warehouse or a data lake, right? So this is a very nice feature, but obviously we are doing the ELT and we load it and then transform it. So I'm not so much of liking one than the other, because at the end of the day, you just load data somewhere and you transform it. So in my opinion, you should do it the most effective way. And if let's say if you have an API, it's not so effective to transform somewhere in between. So I guess it's easier to just load it and then do it with with some compute that is much faster and better. But if you have if the source is a database, they have the compute, right? So you could do it on the way, like the ETL approach. So and we support both. It's not so well known that we do the transformation, and probably I'm a bit skeptical if you do too much of the transformation between. Of course, you have more errors. Because I think Airbyte is also used for, you want to load the data correct and on time, right? So it's the more you do transformation there, the more you actually, can shoot yourself in the feet if you do something too complex. Or so, I think it's always a balance as always. But obviously,
No. I think what you're saying makes a ton of sense, and Saurabh definitely agrees with you. By the way, he's chiming in from LinkedIn as well. And my usual response for that one, by the way, is that even though I often make it sound like I'm a zealot on one or the other, in fact, actually, my usual response is no, choose the right tool for the right job. Like there are scenarios where, for example, if I'm trying to, exactly to your point, I'm accessing just a little bit of a smaller, and small is relative terms now these days. Smaller could literally be gigabytes in all seriousness. So that's perfectly fine, right? In other words, I'm not asking for petabytes when I'm making a statement like this, right? I actually think it makes perfectly good sense when you're talking about gigabytes, especially when you're doing almost like a streaming scenario, right? Where basically you're just constantly pinging the API. You do some minor transformations right then and there, and you're good to go. And bam, you put the information in. By the same token, if you're dealing with tons of data, honestly, you probably need to just dump it somewhere. And so I called it as like a raw immutable zone. I was like, And so, for example, in Delta Lake, we often talk about the medallion architecture, bronze, silver, gold. And the idea is that you have this bronze, which is the whole reason you have this bronze zone is because you're asking for so much data, like Kafka topics or whatever it is your system is, right? You can't keep state, right? For example, just to pick on Kafka, and not because I don't like Kafka, quite the opposite. I'm a huge fan of Kafka. It's just but you usually configure Kafka to only have for example, I was just talking to Tyler Croy yesterday, and he was telling me typically you want to set up at least 4 days, right? So that way, if anything happens for your pipelines and it's a Friday and your Mondays you're taking off, you've got at least 4 days of memory.
It's very scary for a BI developer when you say 4 days. What? Okay.
But you understand what I'm trying to get at. But the idea is typically you don't want to actually have the Kafka topics stored for that long, right? You fine, you set up for 4 days so that way you don't have to be alerted over the weekend if something breaks, right? But the point is in general, what you still have to keep it into some solid state, right? Which is like a data lake. Obviously I'm biased toward Delta Lake, but let's be clear, that's actually applicable to any data lake or lakehouse storage format. That's the whole reason for them, because you just need to get that data down so that way that data is there, that state is complete, and then you can transform it accordingly. Now, which leads me to the question which actually was asked from LinkedIn, and let me go back. Where is there's a question from I apologize if I'm saying your name wrong, by the way, Baba Awale, on LinkedIn. It's can Airbyte actually handle both batch and streaming ingestion? I'm just curious. I actually don't know this. Is there any issues for Airbyte to handle one or the other?
Right now we're focusing on batching, but you can set a cron job that does every minute or so with small data. Of course, it just need the sync itself need to be faster than the frequency you set, right? You cannot set a job that takes 1 hour every minute, obviously. but you can schedule. So it's what is it? The name? The real. No, batch real time, or it's not real time, but micro-batch, exactly.
Micro batching, basically. Yeah. Which is the traditional context of structured streaming, by the way. Same principle. Basically, you basically the time it takes to process the data is better be shorter by half or less, right? Than the time that you're actually indicating for the job to run. So otherwise, all you're going to do is just queue up forever, and you'll never catch up. Basically, So
but. I think we get this question more often. So we're also thinking about how can we have more event-based or more streaming approaches. So that's also one thing that we are discussing. But we are heavily batch at the moment. But
gotcha.
With a high frequency.
Perfect. But this also tells me a little bit, segues nicely into the topic of orchestration. So from the standpoint of Airbyte, like, any preferences or context about how do you typically see folks in terms of orchestrating their pipelines or their ingestion or their processing within the context of Airbyte? I'm just curious.
So either you use our cloud solution, then there's everything works out of the box and you can schedule everything.
Mm-hmm.
If you basically, when you open Airbyte, you have all your connections. So connection is basically you just stitch together a source and a destination. That's also one thing that Airbyte is quite nice at. You can actually connect every source with every destination. So there's no tangling between, okay, you can only, Oracle only works with Delta Lake, or so. That is like one feature. So the source and the destination you put together as a connection, mm-hmm. and the connection, you see all the connection in Airbyte, and then each of them have like a schedule interval. So then you can also do it manually, and we also provide an API. We are working on that to also optimize that, but that's then also we have an integration with Prefect and Daxter. So
perfect.
Then also like use these kind of tools to orchestrate, because normally you don't only have Airbyte, maybe you have a DBT model, and then you have like stuff that you need to orchestrate on top. Maybe you have a machine learning model. So then of course it makes sense to use like a true orchestrator, and Airbyte is nicely integrated in these tools as well.
Oh, that's really good to hear. Actually, as a call of anybody who's actually listening right now, if you want us to include some of the, have another session with our friends from over at Prefect or our friends over at Daxter, let us know so we can go ahead and set that up as well. So even though it seems like it's a wide community, we all work together really closely anyways. At least the open source arms of all of us, we all work really close together for precisely the same reason, because we all believe in the best solution to all these problems involve us actually working together across multiple domains, because this is actually a really hard problem.
I think also it's also something we need to solve, right? We need to have more integrations, because it's sometimes a bit overwhelming if you, for each small thing, you need a different tool, and then you would like to build a end-to-end data pipeline or an analytics system, and then you need to integrate, if you want to be on open source, integrate like 5 tools or so, right? So it's right. I think if we want to succeed more, it's also about integration and to like support each other and have the you can then I just writing about this so the modern data stack and how to fit the tools together. So it's also I think it's nice then to extend, right? You can always choose the tools you want, and then you can extend. So you don't need to start with everything from scratch, but it's still important that you can start up fast and you're not overwhelmed with all these names and tools, which obviously happens quite fast when you start out. Yeah.
Oh, no, I agree, because if you like, I'm sure just because of the nature of Airbyte, you've got 300 different connectors, right? And so the fact is, great, we can all use Airbyte to basically go from source to target, but the reality is that's just one of the pie, right? Then Delta Lake, for example, is another part of the pie. But then, just as you said, Daxter, Prefect, that's another part of the pie. And the reality is, all of us are taking, we're taking, sure, there's a little bit of intersection, or overlap, but the reality is we're only solving one area of the pie. Yeah, one specific area. We have a little bit of bleed over at times, I'm sure, but exactly. Victor just says, sure, it's like an array extended. Like, basically, we're extending over each other, but the reality, it's a huge thing that we are all trying to work together. So the faster that we actually are integrating with each other, and I hate to use the word standardizing because that sounds so corporate, but you also get my
standards, right?
Yeah, exactly. I mean, thank you. Let's just use the phrasing open standards. So we have to use open standards, so that way it's possible for us to interact with each other. So that way we actually will ultimately make things easier for everybody, right? So.
Yeah.
And by the way, Saurabh has been asking about and he asked the question about Apache Beam and Airbyte, right? And so I did want to call out that the reason. Number one, I apologize for not answering that question first. The context of Apache Beam is itself basically is a abstraction layer on top of either Flink or Apache Spark. So it's not specific like to Airbyte itself. Airbyte really is about going ahead and talking to any source and in essence to any target to make your life a lot easier, which we're actually going to talk about a little bit, because this you're referencing about writing about the modern data stack is going to invariably lead me to talk about Rust, of course. But specifically about the question about Beam and Airbyte, Beam is that abstraction layer that that also you hear in Google Dataflow and things of that nature. Airbyte really allows us to go ahead and go talk to Apache Spark, go talk to Flink, go talk to anything, and it just simplifies things. So hopefully that makes sense, Aura, because they are actually sort of addressing different things in this case, right? Beam itself was basically more about like, okay, I want to use Flink or I want to use Spark for everything. Can I just use one abstraction layer over both? It's interesting, but again, not to knock any of the folks who work on Beam, just because I actually have friends who are there, but I personally feel like if you're going to do it, just use Flink or just use Spark directly, because you'll have more control over what you're trying to do. The whole purpose of Airbyte is to go ahead and say, no, like I just need to figure out what my source is. I need to figure out what my target is. Let me go into that.
Yeah.
So hopefully I've answered your question, Saurabh, there. Saying that, let's go back to the modern data stack, because you've been blogging about it, Simon. You've been doing some great blogs on this stuff, which we'll include in the follow-up to this. We'll attach it to this video as well to some of your blog posts. But yeah, let's talk a little bit about Rust, because I did eventually want us to get back to Delta Lake too, which is so yeah. So why don't you bring your thoughts about Rust in terms of like why you feel that Rust is actually a potential important context within the modern data stack.
Yeah, I was just hearing like lots of good things about Rust, right? It was like 7 years in a row the most loved language on Stack Overflow. So I was like really curious, and I was always thinking, okay, I want to learn a new language. And that was either like one of the functional programming languages, or like Scala, or like there's so many nowadays, Julia and all the others. And then, but now I think Rust is really gaining popularity, and actually I blog about that, right? What is Rust versus Python? So I just put myself in there and tried out Rust, and I think it's just a good fit for data engineers, although it's actually a systems language that is maybe on first look it's not made for data engineering. But one disadvantage of Python is obviously you only know when you run things, so you cannot really test things, or you need to test things heavily. So yes. If you have a else statement that never got like triggered, it will trigger in production, and then you.
Of course, absolutely, it will get triggered in production, and you wrote it wrong, so it breaks in production. Yes, absolutely.
And actually, one thing that I like about Delta Lake is enforcing data types, right? And Rust, I see it a little bit the same, but for like programming, it enforces so many things which might be annoying, but it enforces types. It enforces like you need to define your memory and stuff like this. But you get a lot of stuff, or you get like the clarity maybe that you will not run into that many errors in the production. So that's one big thing. And also I think just using Rust, I'm not any expert on it, but just using it was so nice with the compiler that tells me everything while writing. Okay, you should do this, you should do. The error messages are good, and obviously it's also blazingly fast, right? So it's if we want to do data stuff, we have lots of data, so it must be fast. I still think there will always be Python, and you have like an interface to Rust. But if developers liking Rust more, they will also start trying to make sense and trying to use it, right? So they will. So I think it's really getting more popularity, and yeah, that's also a nice thing that I saw in Delta Lake, that you support that and actively having this this repo. And yeah, it can also be one thing that we had a look at is also using Spark with Airbyte. But like we are all Dockerized, so it's quite hard to just spin up like a Spark cluster within our open source. We already have quite some containers that for the UI, for the server, for the database, and stuff like this. So then will be one more. And that will be a bit, I always say Spark is a bit a beast, right? It's a bit hard to tune and do stuff. So, and Rust is there, it's like a single node type of thing. So you can do much easier performance. So that's also, one thing that for big database could be a nice thing to use. Yeah, especially with Delta Lake. Yeah.
Oh, perfect. Yeah. And by the way, so there is a Spark Docker, by the way, an official one now. But even after saying that, like, which I do talk about, I'm with you 100%, right? You know, Rust, by the way, just as a call, because I'm going to time box it because I do want to answer Saurabh's original question back to analysis services again. But we do actually have a D3L2 session that happened last month. Oh, right now it's December, by the way. So just in case you're watching this later, last month with Florian, who actually built, who's a maintainer, Delta Rust maintainer, and he focuses on the Python APIs. Exactly to your point. I think the Python API is beyond here to stay. It is the standard that we all work off of, right? By the same token, there's a subset of us that actually work off the Rust stuff. And then, by the way, again, because today's December 6th, on December 8th, we actually have the genesis of Delta Rust with QP How. So, well, don't worry, we'll dive into that. But I really, the reason I brought this up is because I really enjoy the fact that even somebody like yourself and myself, like who come from database backgrounds, we're actually talking about Rust. And so what's interesting, and I've used this phrase from Dave Mariani, I want to attribute it to the right person, by the way, is that we're over the last 10 years or so, we've seen this convergence of data engineering and software engineering. Like, it's never going to be always the same, but the point is that we're starting to apply software engineering principles directly into data engineering, right? So that we actually care about types, we care about how memory management, things of that nature. And to your point exactly, Rust, which is seen as a systems programming language, yet exactly to your point, it's being applied to software engineering in general, like from a functional operational perspective, and it's being applied to data and engineering because we're seeing this convergence of software and data engineering, which is really cool, right? I really like that fact, which then leads to the one little tidbit, which is Simon and I have actually been working. So if you join us on the Delta Rust Slack, we've been actually working on with the community, the Delta Rust community, on having a Airbyte to Delta Lake connector. Now, so right now there is one already for Databricks, but we want this one to be here for the open source community. And we're pretty close because, just as Simon called out, there is a Python CDK, a connector development kit that makes it really easy. And of course, Delta Rust has the Python API. So that's exactly what we're working on right now. So there's actually 2 or 3 GitHub issues open from the Delta Rust side that we got to go fix. So we just released Delta 0.5.0 and Delta Rust 0.6.4. So we're pretty close to getting ourselves there. And so if you're interested, come join us in the Delta user Slack. That's go.delta.io/Slack. Okay. Delta RS channel. And you can join us there and to talk about how you can go ahead and basically build it. Once we do that, I'm hoping Simon and I can actually, and whoever helps us build it, can actually have another session in the near future specifically on this. Right. So anything that you think that we should add as a call up, because I'm pretty sure I called out everything, but I just wanted to call anything that you thought I might have missed here.
No, I think you wrapped it up very well. So no,
cool.
I think yeah.
Yeah, right. All right, perfect. Well, then let's go. Let's see. Okay, we've got most questions are pretty much been answered. So let me just at least end with Saurav's little call out. It's like, so he's wondering. So just because Simon and I both from analysis service. So back to that little tidbit. He's wondering. He's like, for that cube, that 24 terabyte cube on analysis surfaces against the 5 petabyte or 2 petabyte 5,000 node Hadoop cluster. How many servers were we using? As scary as this sounds, and Simon, you're probably going to freak out when I say this, okay? 1. We got this on 1 server. Now, we did replicate this over 3 times because we did clone it. So here's actually how we did it. We had physical clone of one of them, and so that was our backup. It was a backup cluster. So the idea is it's just if it's processing or it blew up, or if it's processing and taking too long, then people can query that backup. We also did 2 replicas. We also do 2 logical clones, which were basically aimed at the same Clarion or whatever hardware we were using at the time, which basically it could go ahead and, in essence, you had the analysis server's query engine, in essence, running in the server, But the storage engine, and I'm being very facetious when I say that because in analysis services, there actually wasn't a split between the two. But basically, the storage of the indexes, the maps, and all these other things that were in analysis services were actually stored basically on and where multiple systems could go hit it at the exact same time. The reason we could afford to do is because typically when we're processing the data, we process it on a completely different server. It's a completely different setup. So and also replicate the data fully. So that way we weren't trying to overwrite because after all, it's running a day and a half to 3 days, right? So we weren't trying to overwrite. But in essence, yeah, it was the one primary server were two clones, logical clones, hitting it at the same time. So
Wow.
Yeah. So which incidentally, and I'm sure with Simon's face there, not optimal.
Yeah, how did you scale it down to 0?
No. Well, see, that's the whole point. How they scaled it down wasn't by scaling it down. How they scaled it down was basically they went ahead and started working with Spark.
Yeah, that's just that was our. I still worked with analysis service like the last 2 years ago, and that was still our problem, right? So how can you scale it down when you don't use it? So that is that wasn't that easy that time. You had to buy the whole server.
Yeah, exactly. You had to buy a whole server because this wasn't a cloud environment. So basically, like, and don't forget, remember, I know the fact there's a Oracle rack server behind all that. You can't scale that down either. We're talking like a bunch of hardware, not cheap at all. That was basically hitting the Hadoop cluster, and of course the Hadoop cluster with the thousands of nodes. I'm like, yeah, we're basically beating the living daylights on this thing. So yeah, fun time. Cool. So I think that's it for today's questions. I noticed a bunch of laughy faces or smiley faces or people wondering, but yeah, like it is what it is. Oh, please go
one
for
last
it.
block. Just if people are interested, we have like a data engineering conference tomorrow and the day after. So in the case you are interested, we have like also big speakers from Databricks. We have one. So we have all across the modern data stack. 2 days, only 2 hours. So it's like only lightning talks. So in case anybody is interested, it's like move.airbyte.io.
Yeah, it's the Move Data Conference, right? Did I get that correct? Yeah. All right.
Correct.
So you know what? Just to help everybody out, I am posting that into all 3 channels. If I can find all 3 channels. Okay, here we go. Sorry. There we go. All right. So I've posted. Yes, everybody. I think there'll be a great session for you all to join. So there's the Move Data Conference, the 7th and the 8th. So you can join that. I'll make sure to log in if I haven't done it myself. So this is great. And then just as a plug, because both, as you can tell, both Simon and I are very much into Rust. QP is this Thursday. He and I are going to talk about the genesis of Delta Rust, and it'll be a fun conversation there too. So Simon, I thank you for your time. I really appreciate it. You and I are hopefully going to have another session, okay?
Yeah.
Later on, in which we'll be able to talk about the Delta Lake and Airbyte connector, the open source one that works well together. So because we're pretty close, but we're not quite there yet. So like I said, but hopefully we'll have a session on that. But again, thank you very much for your time, and for the audience, thank you very much for your time for listening to us and enjoying our complete and random offshoot into the world of analysis services. So.
Thank you so much for having me. That was a blast.
Awesome. Have a good one, everybody.